Okay, students, so if you recall, in the previous video, we started with the pulley example. Um, so we completed all of the steps up until the assembly. So we have already created the three components. Remember, all of our units are in inches. So we created the bracket, we created the pulley, we created the pin. And then finally, we build each component and we created a draft on just one of the components. Same thing for all three of them. If you want to do a draft for all of them, you can do that. And in this video, we're going to actually assemble the components together. Okay. So the components we have is the bracket, looks something like this, and then the actual pulley, and then finally the pin. Okay, so we're going to use all three of those components to actually generate that assembly. Okay, so I'll jump into Fusion, and here we can see the three components. Okay, so we have the bracket, we have the pulley, and we have the pin. So what I'll do first is I'll start a new design. So this new model is going to be the actual assembly file for where I'm going to assemble all the components together. But before I start doing anything else, the first thing I need to do is I need to save this component. Okay, so I'm going to save this model as pulley assembly. Okay, now the reason we need to save is we absolutely need to save first because we need to have a destination folder to actually send the components into to actually assemble together. Okay, so now that I have this destination, all I really need to do is open up the data panel, and here I can see the three components: the bracket, the pin, and the pulley. And what I'm going to do here is I'm going to actually attach each of those components into my assembly file. Okay, so there's two ways that we can do that. The first one, which is probably the easiest, is I can just click and drag the component and drop it into the environment. So in this case, I can click and drag the bracket first, like so, and that's going to automatically add that component into my environment for the assembly. Okay, now the first thing that Fusion does as soon as you add a new component into an environment, it's always going to allow you to move it. Okay, so it's going to ask you this because it doesn't know what's the actual position of the component where you want it to be. Okay, so we have three adjustments we can do as far as a position. So we have this movement, which is my Y, we have my X, and then we have my Z. Okay, so that's location. But on top of that, we also have three different angles. Okay, so we have this angle about Z, we have this angle about Y, and we have this angle about X. Okay, so we can use all of those degrees of freedom to actually place this new component in the environment. Okay, so I'm gonna actually leave everything at 0. I can always cancel it, and then it's gonna go straight back to where it was. So I'm gonna leave this in the original position. Okay, I don't want to move it, I don't want to do anything crazy with it. Okay, so it's gonna stay there. Now, the first thing I'm going to do here before I do anything else is I'm going to make sure that this bracket doesn't move. I don't want it to go anywhere. I don't want it to accidentally click and drag and I just moved it. So instead, what I'm going to do is I'm going to open up the bracket. So select it and then right click, and I'm going to hit ground. So by grounding, I'm essentially locking in place the current location and orientation of this component. Okay, so this component is no longer going to move, and it's no longer going to rotate in any of those 6 degrees of freedom. Okay, so again, a lot of stuff going on. If you still have questions, rewind, take a look at it again. but just sort of try to understand everything that's going on, right? So again, the first way I added this component is just clicking and dragging. Now what I'm going to do is I'm going to add the second component, which is the pulley. And instead of clicking and dragging, what I'm going to do is I'm just going to right click and I'm going to put insert into the current design. And it's essentially going to do the same thing. It's going to grab that component, it's going to insert it into the current design, into the environment, whatever you want to call it. Okay. Now this one here, I'm going to actually move it a little bit. And the reason for that is I sort of wanted this thing to have the correct space. Okay. All right. So there we have it. Now what I'm going to do is I'm going to put it pretty close to where it should go, but I'm still going to want some space. So what I want to do is I want to be able to rotate the environment and be able to select and have enough space to view the different edges and things like that, which I'm going to need to actually assemble this. So I'm going to hit OK there. And then finally the pin, I'm just going to add it as well. Now the pin is perpendicular to the way it should be. So this one definitely needs to be rotated and adjusted and all those good things. Okay, so something like that. I'm gonna hit OK. Now, what I'll do here is I'm gonna first assemble the pulley into the bracket. Okay. Now the way we assemble things in Fusion is we use relationships called joints. So I'm going to have a joint between the pulley and the bracket, and then of course I'm going to have joints between the pin and the bracket, or the pin and the pulley. And then those joints, those relationships is what's going to make them sort of hold together. Okay. So to create a joint, you can either look for joint up here, or you can just type J in your keyboard. And what it's going to ask you to do is, the first thing it's going to do is it's always going to ask you to select what two components you want to join together. But it's not just selecting the components, it's actually selecting the things that are going to come into contact, the parts of the component that are going to be creating that relationship of a joint. Okay, so in this case, what needs to happen, if you think about the pulley and the bracket, the pulley has to be joined to the bracket by this edge here, right? And of course there has to be a free rotation between the two. So the pulley itself should be able to rotate freely up the bracket, but it shouldn't be able to be moved out of that place once it's locked into it, right? So it should be able to rotate, but all of the different displacements shouldn't be able to be changed, and the other two rotations shouldn't be able to change. So what I'll do here is I'll select this edge of the pulley, and I'll select the edge that has to come into contact with that one, which is this inside edge of the bracket. And as you can see there, they are sort of joined together, but it's not quite doing what it's supposed to do. So that shaking movement, what that represents is this thing, or this joint, called a rigid joint. And if I switch from position to motion, I'm going to see a list of the different types of joints that I can select. Okay, now here if I animate it, both of them shake, and essentially what that's telling me is that now they're both joined together, but there's absolutely no degrees of freedom between the two. What that means is that they're essentially welded together. So wherever the bracket goes, the pulley is going to go straight with it, and it's not going to have any free rotation, which is not going to work for me, right? So in this case, we have to look at one of the other types of motions or joints that we can select and try to figure out what each of them are doing. Okay, so revolute, as we can see there, what it's doing is it's limiting all of the degrees of freedom except for that one rotation, and I can select which axis I want it to rotate. So I can do the x-axis, that doesn't quite work. I can do the Z or the Y, sorry, that doesn't work either. Or I can do the Z, which is what works. That's exactly what I need, right? So in this case, the revolute joint, what revolute does is it limits all of the 6 degrees of freedom except for that one rotation. Slider does exactly that, which is pretty much limiting all of the degrees of freedom except for one movement or one translation. And of course you can select which one you want. So you can select the X, you can select the Y, or you can select the Z. Okay, that's not what I need. I don't want this thing to move out of place, right? So slider doesn't work for me. Revolute seems to be working. We have this thing called a cylindrical, which is allowing 2 degrees of freedom. It's allowing one rotation and it's allowing one translation. Okay, and of course you can select which one it does it in. So we can rotate about the X, Y, or Z. Okay, so in this case I want the Z, but I don't want it to shift out of place. So again, it's I still need to limit one more. So cylindrical is not working for me. And then we have things like pin and slot. This one seems to be doing similar to what cylinder was doing, except on 2 different axes, one for rotation, one for sliding. So again, this is not gonna work. And then of course we have planar, which is just like 2 separate planes, but they're free to do whatever they want. So we have freedom in one rotation, and then we have freedom in 2 different planes for the actual sliding motion. And then we have things like ball, which is just like all kinds of craziness, right? So we have to be careful with that one. Ball we don't really use that often, but out of all of them, the one that seems to be working the most or the best for us is revolute. So again, all you have to do from here is really take your time to try to understand what each of them are doing and how each of them are limiting the number of degrees of freedom between the 2 components. So there's only a total of 6, 3 translations, 3 rotations. How is each of these joints limiting those between the 2 components? Okay, so again, in this case, revolute is only allowing one rotation, which is what I want. So that seems to be doing what I wanted to do. So I'm going to hit OK. And I can always test it. Once they're joined, I can just click and drag and they should be able to move freely of one another. Now, in this case, it's working because remember, I grounded the bracket. So that bracket is not going to move on its own. So that's what it's allowing me to actually do this type of animation, if you will. Okay. If you don't ground the bracket and you try to do this like click and dragging, then your components might just be moving all over the place. So just sort of be careful with that. Okay. Now finally, for the pin, we just need to sort of repeat the process, right? So I'll go ahead and hit joint. I'll capture the position. And then what's going to happen here is I'll just again need to select the points of contact, right? So in this case, I'm going to select this edge and I'm going to select this edge. And as you can see, the pin seems to be rotating freely off the bracket. Now, there's a couple of ways that can work. So usually the pin is rotating at the same speed as either the bracket or the pulley, but not both. Okay, so what I'll do is I'll actually sort of weld, if you will, the pin to the bracket, and then of course the pulley is going to be able to move freely from the bracket and the pin. Okay, so my motion or my type of joint, I'll just do a rigid, so the pin is not going to go anywhere from the bracket, so it's always going to be stuck together. Picture it as a weld, and then I'm just going to hit OK. Now if I zoom in and do the rotation, we can see how this assembly seems to be working pretty good now. Now again, if you recall, The reason I did those details on the pulley, those shapes, is so I can actually see the pulley rotate. Okay, and as you can see, nothing is falling out of place, everything's sort of sticking together, and it's just allowing me that one rotation. So this assembly is now done, everything's working the way it should be. We're good to go. Okay, so again, if you have any other questions with assemblies or any of the other ones, please make sure you review the videos, and you can always shoot me an email. Now, a couple of things to take from here is we might need some revisions on some of the components. For instance, if we take a look at this area here, that pulley seems to be ending right where this surface is, so there might not be too much tolerancing there. So we might be able, or we might think about adjusting the bracket to allow a little bit more space there. Also, if you were to use this pulley, for instance, with a rope, notice how this shape of the space is only accounting for half the rope. So we can probably make some adjustments to the bracket as well in that sense. Okay. Now what I'll do here is I'm gonna save this component or this assembly, and then what I'm gonna do is I'm gonna jump back to my bracket, and I'm just gonna make some very subtle changes. So I'll go ahead and open up the first sketch, and here what I'll do is I'll adjust that first dimension, that 5. I'll adjust that to 6, so I'm making this a little bit taller. And what I'm also gonna do is I'm gonna include a circle here. That way, when I do my extrusion, I'm now giving it a little bit more space. Okay, so all I did is I made the bracket a little bit taller, and then I accounted for that space on the inside, and the rest of the components or the rest of the steps within this component automatically adjusted and updated. So now this is the new bracket. I'm going to save it, and then when I jump back into my assembly, notice how I get this warning. It's telling me, hey, one component is out of date. Please update the references, and then that way the assembly will be updated. And as you can see, we have the bracket here. It's showing me that little error icon. So all I really need to do is go up here and hit get the all latest, and what that's going to do is that's going to automatically update all of the components to the last version of whatever it is. Okay, so in this case, that subtle change makes a huge difference in my design. Okay, and really, if we're not visualizing all of those things within an assembly, that might have been hard to catch just by creating different designs, right? So again, this is how you actually use CAD to take a look at things like tolerancing, make sure that things actually make sense once you assemble them together. Okay, so in this case, that change seems to be making all the difference in the world, so it now makes a lot more sense. Okay, so I'll go ahead and stop this video here. Again, if you still have questions about assemblies, you can shoot me an email. Try to understand everything that's happening here, and we'll also try to give you more examples on assemblies and different concepts within Fusion. Okay, so I'll see you in the next video.